Hello everyone, welcome to Pseudoscience Podcast. Today's topic is quantum entanglement part 1. Firstly, both the words sound too heavy for a person who doesn't know science. When a science guy uses these words, he thinks that he is sounding cooler among his bunch of his friends. Quantum entanglement. Let's break down these words and know its meaning. What is quantum? Quantum means a small quantity of something. What is entanglement? Entanglement is a sort of connection or relation or a dependent relationship. So putting it together, a small quantity of something which has a dependent relationship. Sounds a bit awkward. Okay, jokes apart, let's get serious. So, according to physics, quantum means a discrete quantity of energy proportional in magnitude to frequency of radiation it represents. So what exactly is quantum entanglement? The entanglement of particles which describes a relationship between their fundamental properties that can't happen by chance. This could refer to states such as momentum, position or polarization. Knowing something about one of these characteristics for one particle tells you something about the same characteristics for the another. To get a deeper idea about this quantum entanglement, let me give you an example. Think of a pair of gloves. If you found a right glove alone in your drawer, you can be certain that the missing glove will fit your left hand. The two gloves could be described as entangled, as knowing something about one would tell you something important about the other that isn't a random feature. An entangled system is defined to be one whose quantum state cannot be factored or product of states of its local constituents. That is to say, they are not individual particles but as an inseparable in whole. In entanglement, one constituent cannot be fully described without considering the others. The state of composition is always expressed as a sum or superposition of products of states of local constituents. It is entangled if this sum necessarily has more than one term. Entangled particles remain connected so that the actions performed on one affect the other, even though they are separated at greater distance. Albert Einstein called this phenomenon as spooky action at a distance. The transfer of state between the photons takes place at a speed of at least 10,000 times of speed of light, possibly even instantaneously, regardless of the distance. For instance, a spin zero particle could decay into pair of spin half particles, since the total spin before and after the decay must be zero. Conservation of angular momentum, it is called as. Whenever the first particle is measured to be spin up on some axis, the other then measured on the same axis is always found to be spin down. So that's it about today's episode. We have learned about quantum entanglement concept. Do share your comments and theories of this episode with me through Instagram, Facebook and Twitter. And if you want the visual experience with graphics and animation of my episodes, watch them on YouTube and subscribe to my channel Dheeraj Kalapuri. Okay, now we'll meet you in the next episode with a new sci-fi topic. Until then, goodbye. Stay safe, stay tuned.